All right, here's 5-2, day 3. So far we hit kind of the basics of logarithms and their properties, and then we did some graphing in day 2. And now we're coming back to an old friend of ours, base E, right? We looked at that a lot on the exponential side of things, and now we're going to take a look, right? If that was your base, how does that show up with logs, right? Because remember, it's kind of a weird base, right? Just to kind of recap, E, it's like 2.71828, except it goes on forever, doesn't repeat. It's got this weird deal that if you want to look at huge x values, right? We call that a limit. It's the number you get if you put massive x values into that, right? 1 plus 1 over x to the x power. You get like 2.72, okay? So if you are dealing with E, right, it has an inverse that's a log. We call it ln, right? Remember, we call it this like continuous compounding thing, right? But it's one of those things. It probably might be a little bit difficult from all this to see why they call it a natural log. But what they're saying is basically because the number arises from this case, that's considered like the natural circumstances of this, like 1 plus 1 over x to the x power, that it's the base that we love to use that occurs naturally if we're doing continuous growth problems. So it gets called the natural log, right? That's what you got there. Now, don't let me catch you doing this. Log of e to the x. It doesn't get written like that. We call it ln, okay? Now, if we were to go to evaluate, we're probably going to be pretty calculator dependent because here's the thing. Here's the question we're looking at. For part A, e to what power is 2, right? So if you think about that over here, right, with kind of a number value for like 2.72 to what power equals 2, that's a little tricky, right? But go to your calculator. Right along that left side is probably where you're going to find it. Whether you have a TI-84 or a TI-30, that's where you're going to see it. You should see somewhere on there, there's an ln button, right? And what you would type in is literally just this, right? ln of 2, which is like 0.693, which again is addressing this question. If you took e to the 0.693 power, that's what you're going to get. You should expect lots of decimals when you're working with natural logs, right? Looking for a y value from the natural log of 0.3, which is saying e to what power is 0.3. Again, if you're kind of losing sight of what's happening there, just go to 2.72, right? When you see e, think, all right, 2.72 to what power is 0.3, right? Calculator-wise, you'd be throwing that in. And for your answer, you would be getting about negative 1.2, I think is what you get here, like negative 1.2. Now, check over on the graph here, okay? We had looked in day 2 at a bunch of graphing stuff, right? And we specifically said, like, hey, here's all the properties you're going to find with graphing if your base is bigger than 1. Okay? Well, guess what? 2.71828 is bigger than 1. One of the characteristics that we expected to see is that there's an asymptote at x equals 0, right? And then a domain of x greater than 0, and natural log fits the bill, right? The same properties graphically would apply, right? So here you're looking at e to what power would be negative 1, and you'll end up getting an error, right? That negative 1's not in the domain, right? But all those graphical properties that you saw in day 2, they all apply, right? Natural log fits the criteria that we were looking at, and you can see from over in the graph here on the right, it kind of, right, it when we looked at log base 2 or 3 or 4, I think it really only got real deep into log base 2 on the graphical side. It looks really similar, right? And really when we did the shifts and the transformations for log base 10, it looks pretty similar. Okay, nothing very enlightening here on the property side of things. Really the thing to see is, you got these 4 properties, I think a couple of lessons ago, and I had just said, here, if your base is bigger than 0, and if your base isn't 1, right, these 4 properties would apply. And again, E, or about 2.72, once again fits the bill. So the 4 properties that we saw before still apply, okay? So number 1, I'm going to get a little creative here, that 1 over E, right? I'd need to apply a property of exponent and recognize that. That would be e to the negative first power and that's really going to property number 3, that if you're taking the natural log of an exponent that's base e, they'll cancel and you'll get -1, okay? Just like part B, okay? E to the natural log of 5 power, those would cancel out, and you're going to get 5. It's all over 3, but that doesn't, the over 3 is fine. What really gets my attention is the natural log of 1, because that reminds me of this. And I could immediately say that's 0 over 3, or just 0. And last over here, we see natural log of e times 2. Right, this takes me right to property number 2. This would be 2 times 1, or just 2, okay? Kind of went through those pretty quick, but honestly, all those problems fit the properties well, so there's not a lot of work to show, and the properties aren't new, right? Natural logs follow all the properties of other logs. We're just using E as the base. All right, here's a little application problem, which you'll see natural logs come up all the time in applications, all the time, okay? They fit a lot of models in real life data pretty well, okay? This is a psychology experiment, right? But kind of an interesting thing that would look at, like, all right, you've taken a course of some kind or studied something new to learn some new knowledge and skills, okay? We know as soon as you were to stop being engaged in studying that material or learning that skills, and if you didn't use it or practice it, you're going to lose them, right? But what this human memory model gets into is, okay, in what way and at what rate? Okay, now we're not getting into the graphical side, but what you would see on this, because it does have a bunch of transformations going on, including a reflection. Right, so I think it has more of that look like that. We saw one of those in the second day where I reflected a logarithmic graph, but it would decrease really, really fast at first, and then it slows down. Okay, so that's actually kind of what you would expect to see, that if you were to measure your skills after a course, they'd be pretty sharp, and you have a lot of that information right when it ends. And then as time were to go on, you'd probably lose some of them pretty quickly, but then it would slow down. And then you'd have kind of like the knowledge and skills that you're going to hang on to long term, right? And this is kind of an interesting thing from a school perspective, that if you do a good job with the course, hopefully those skills that you're hanging on to long term, right, where you start to see that the score here, and we'll say that score kind of represents the amount of information you retained. Hopefully it's the most important stuff, right? If it was a well-designed and well-taught course, that's kind of the idea. you'd hang on to it long term. So the first one here, I would expect I could just evaluate it off of properties, because that's all that's really going on here is we're just evaluating. I don't need a calculator on this one. I have 75 minus 6 times the natural log of 1, right? But wait a minute, natural log of 1, that takes me to my properties. That's 0, right? Which means that would just be 75, right? So you can tell that's that number out here, which represents the vertical shift, is pretty significant. That would be like your baseline score for the average, right? This was, I think, for several students that were participating. So that was kind of the average knowledge right at the end of the course. Nothing crazy going on with the others, right? What would it be after 2 months? Right, just plug in 2. The thing you'd notice here, however, you'd end up taking natural log of 3 right at this point. That you're going to need a calculator, right? So you kind of see a contrast here. And I'd kind of expect you to kind of navigate them as you're able to in your homework assignments, right? Part A, I can use properties. Here, nope. You get 68.41, and then part C, right? Same deal. You're going to run into calculator, right? Because you plug in after 6 months, right? We're expecting to see the score a little bit lower, maybe starting to slow down some, right? Now that you're at 2 months to 6. But natural log of 7, you need a calculator for that, okay? You could, as you see it, you could type it all in at once, and you would get 63.32. Let me just double check that that's the case. Yep, sure enough, 63.32. Okay. So really, the big picture with natural logs, their meaning that it's just a logarithm that's base E. They follow lots of the other properties that we've seen, and make sure you're okay evaluating them on your calculator. That's kind of the big thing for day 3.